They already have drawn the example 1 angle for us. We are just going to use the 3 steps from up above to construct an angle bisector. So I'm going to put the sharp end of my compass right here on point A. I'll put my sharp end of my compass here. And then my pencil end needs to be a little bit further away, maybe halfway out, so that it's big enough for me to draw an arc that will cross both of the lines. So, looks something like this. Okay? I am now going to put a point right here and right here where that arc crossed the top and bottom lines. They said they named theirs C and B, so I'll name mine C and B. All right, it then says we're going to take our compass and put the sharp end on C and draw a small arc, and put the sharp end on B and draw a small arc. We should be doing this without changing the width between the two, okay? So whatever your width is set to, whenever you put your sharp end on C, there's mine. I'm not going to change the width. I'll pick it up, come put my sharp end on B, and make the exact same mark. And then they're going to cross and look something like this.
Is it the same width you make the?
No, not necessarily. It doesn't matter. Any width you want that's going to fit in between those two lines. But whatever you use when you're on point C, use the same width when you're on point B. All right, so now we have the cross like it said we would in step number 2. Step number 3 says now we're going to draw a ray. It says to label the intersection of these two small arcs right here, G, and then use a straight edge to draw a ray from A through G. So it would look something like this. All right, so I should be able to make a few different statements now about what I see here. First of all, we should know that these two angles here and here are congruent, right? So I'm going to be able to say that angle CAG is congruent to angle BAG, right? All right, now I should also be able to compare each one of those angles to the entire angle that we had before it was bisected. So the entire angle would be angle CAB, right? So the measure of angle CAB, which is the entire angle, would be equal to how many of one of these smaller ones? If I half one of these smaller angles, it's going to be equal to the whole angle?
Wait, can you repeat the question?
So how many small angles does it take to make up the whole angle? 2. So I would say that the measure of the entire angle is equal to 2 times the measure of one of those smaller angles like CAG. Okay, I could also say the opposite if I'm talking about one of the small angles. So the measure of angle BAG, let's say. That would be this one down here. What would I have to do to the whole angle to make it equal to BAG? What would we do? Right, divide it by 2 or half it. So I could say that it's equal to half of CAB. Good. So those are all statements that you might see being made if you've created an angle bisector. The two small ones are equivalent to each other. The small one could be doubled to make it equal to the large one, or the large one could be halved to make it equivalent to one of the smaller ones. Okay, let's see here. Let's do that again on example number 2. All right, so I'm going to put my sharp end right here on the vertex A, pencil end somewhere out here, and I'm going to make an arc that goes through both of these rays. It looks something like this. And I'll put a point where that arc intersected each one of those lines. Okay, I'm going to call my points B and C again. And if you want to keep the width the same, you can. You don't have to change it to some other width, but I'm going to put it on the sharp end on C and make a mark. And then without changing the width, I'm going to put the sharp end on B and make the same mark. Now, depending on how big or small your compass width is, these could be crossing at making a wider or smaller arc between the two. So as you saw here, it was pretty wide on this one up above from here to here, and this one is smaller between here and here. Just depends on what you have your compass width set at. Okay, now that I have my two small arcs that are crossing, I'm going to call that point G. And then my third step would just be to take my straight edge and draw a ray that goes from A through G. So it looks something like that. And we can make a few statements here. We can say that we now know that AG is the bisector, right? So I could say that AG, remember this is a ray, that's how we denote a ray, two capital letters with the symbol above it, bisects the angle BAC. We now know that the two angles we created here, I'll just name them angle 1 and angle 2, should be the same size, right? That's what an angle bisector does. So now I can say angle 1 is congruent to angle 2. And we can make the two statements that we made up here about comparing one of the smaller angles to one of the larger angles. So the entire angle, which would be angle BAC, would be equivalent to would be equivalent to 2 times one of the smaller angles. So 2 times either one of these, 2 times angle 1 or angle 2. While I could say that the measure of angle 2 would be 2 times, would be equal to 1/2, the measure of the entire angle BAC. So the entire angle can be comparative to the small angles written in either one of these forms here. All right. So if you'll flip it over on the back, they're going to ask us a couple questions about constructions here. So this also includes previous constructions that we've done. Okay. All right. Number 3 says, the diagram below shows the arcs and segments used to construct the line MN. So MN is the one down here on the bottom. It says you were given point P and LR, the line up here. MN was constructed to be parallel to LR and to pass through the point P. It says, based on this construction, which one of the following statements is not true? So again, this is what's not true. QR, which would be this piece right here, is equal to PN, this piece right here. Is that true or false?
True.
That one's true. Okay. So that one can't be it. All right, angle RQP would be this angle right here, is equal to the measure of angle QPM. So QPM would be this angle here.
It's true.
It's true because those are what kind of alternate interior. Very good. So this is true because of alternate interior angles. Good. All right. H says that angle LQP would be this one here. Oh, I'm sorry. Thank you. Says angle LQP, which is this one right here that I marked with 2 lines, is complementary to QPM. QPM would be this one right here that I had previously marked with 1. Well, those two aren't complementary. Those two are supposed to be what? Supplementary. Okay, so this would be the one that is false. Supplementary means they add up to 180. What does complementary mean? They equal what? Supplementary means they add up to 180. Complementary means they add up to... What is it?
Wait, what did you say?
Supplementary means they add up to 180. Complementary means they add up to 90. So this means adds up to 90 degrees. And then this last one said that QPM would be this one here, and NPQ is this one right over here, are a linear pair. Well, that's true. They are on a straight line, so it can't be that one. All right. Okay, we got one question left. All right, this one says that they used a compass and a straight edge to construct the segment FH right here, given the triangle DEF. Based on the construction, which statement is not necessarily true? So again, we're looking for something that could potentially be false. All right, here they say that DE, which is this line down here at the bottom, is equal to EF, this side over here. Do we know for a fact that that's true? Okay, so this could potentially be wrong. We have no idea if all the sides are congruent or not. They didn't tell us, right, that it was an isosceles or even that it was an equilateral. So we don't know about that one just yet. B says that the measure of angle DGF is 90 degrees. DGF, that's this angle here. Well, if this was a construction that goes from the vertex straight down and intersects a horizontal line, they should form a 90-degree angle, right? It would appear that this looks like it's a perpendicular bisector, right? Okay, so it can't be that one. Well, if this is a perpendicular bisector, it says that DE, the bottom line, if you half it, would be equal to GE, this portion right here. Would that be true? Yeah. Then it says that DG, this portion here, is equal to GE, this portion here. Would that be true? Yeah, so it would have to be A. We do know if this is a perpendicular bisector that FE and DE should be congruent, but we don't know for a fact that it's also congruent to DE.